Gabe. If you want to open up your textbook to lesson 17.
Mr. Deshane, please call extension 3214. Mr. Deshane, 3214.
I'll say it again. Just make sure you open up your lesson to your book to lesson number 17. That is where we're going to be working today. Miss Charmaine keeps misplacing her stuff, and she wishes she would stop doing that. Not talking to you, talking to myself. I'm like, let's go, Miss Charmaine, get your stuff together. Oh, there we go. Got it, Gabe. Okay, so I'm going to start sharing my screen. Here we go. It'd be cool if I could just click on this, because that would be cool. I'm going to go like that. And here we go. Okay, today is 11/2. So we have Cindy, Missing, and Gabe. Wonderful. So my friends, like I said, you guys all have your textbooks, so please open up your textbooks to lesson number 17. Or if you don't have your text yet, please make sure you open up to the slideshow for today. Okay. So like I said, if you are at home, can you please open up your slideshow for the slideshow today? If you have your text, open up to the lesson number 17. We're going to get started once everybody comes back from Encore. Don't know why we're not all back yet, but whatever. I'm going to do the chit chat. Here we go. Okay, if you're in here and why don't you start to take a look at the warm-up? So it's that first page in the lesson 17 or slide number 3 if you're in the slides. Please take a look at, if you were a babysitter, would you rather charge $5 the first hour and $8 every hour after that, or would you rather charge $15 the first hour and $6 for each additional hour?
Extension 3211.
Where is Mr. Walling? He is very late this morning. Not cool, not cool, not cool. Okay, here we go. Everybody is on their way in. Come on, guys. I need you coming in right away. Get your book out. We're getting started right away. We're running a little bit behind. Come on in, grab your textbooks, please. Open them up to lesson number 17. Open your textbooks up to lesson number 17. We're getting started right away.
I'm sorry if I kept a couple minutes late. We had such fun. This is a really good group. I will see you guys Tuesday?
Next Tuesday.
Depending on whether the Civil War takes place.
Yes, it could happen.
Um,
Okay, here we
do you have
go.
these boxes out here?
Do I need them? No.
Thank you.
Yeah, go ahead. So you are a babysitter. You're opening to lesson 17. We're done with the chatting. We're getting right into math. You are a babysitter. You have two options for the pays that you can ask for. First, you can charge $5 for the first hour and $8 for each additional hour, or you can charge $15 to start and then for the first hour and $16 for each additional hour. Which would you rather do? Which babysitting scenario would you rather take part in? The first one or the second one? And tell me why. Okay, we're taking a minute and a half to do this right now. Which babysitting scenario would you like to take part in? Okay, once my friends at home start to make the decision, you tell me, would you rather choose A or would you rather choose B? I want everybody at home to tell me, which would you rather choose, A or B? Nice job, Gabe. Thank you, my friend. So we don't need our Chromebooks. You should have your textbooks.
Mine, it's at my dad's.
Do you want like two, or will you?
I have an extra one.
Okay, so do you want to give her your extra one? And then why don't we sort of just have both of them, and then like leave one at mom's, leave one at dad's, and then figure if you try to remember, and if you don't, just grab the other one, the extra. Any question? Nope. You make that choice. You can say, I would choose this one for this amount of time and this one for this amount of time. That is an acceptable response if you would like to. Nice, Ava. Oh, I didn't see you. See how many participants we should have? 5 then? Oh, okay, perfect. Awesome. Thank you, Ava. Perfect. Wonderful. We're taking another 2 seconds, and then we're coming back together. Okay, so Ava said she would choose A. Gabe said he would charge the $15 for the first hour, and then the $6 for every additional hour. And then he said because I would have $21 after 2 hours, with the other one, he would only have $13 after 2 hours. Awesome. I like that, Gabe. He gave me a reason why as well. Awesome, Gabe. Perfect. Does anybody else want to share out in here which one they would choose? I'm going to go Max and I'm going to go Peyton. Go ahead, Max.
I would rather choose option number 2 because I would always make at least $15. And another reason for this is because for the option number 1 to make more than option number 2, I would have to babysit for at least 6 hours.
Very good. Nice. Very good. $15. What were you thinking, Peyton?
The way I did it, I did 6 hours. So like the first hour I put 5, and then I put 8, and then I put 5 beats.
Yep.
And then for the second one, I did 1:15, and then 5 6s, and they both equal the same exact thing. If I did 6 hours.
So you found that the 6 hours, they had the equal amounts? Good.
Yeah.
So up until 6 hours, which one makes more? Abby. B makes more up to 6 hours, but if you work for, if you babysit for more than 6 hours, which plan should you go with? What do you think? Number one. So you want to sort of maybe do a little bit of research. So if you're like a babysitter and you're going over to someone's house and they're sort of interviewing you, because I know they interview. I had an interview for one once. And we sort of like get a little taste of what's going on. So how many hours do you think you're going to need me for? And if they're going to go a lot of hours, like I babysat during the day for a family, and A would definitely be the way to go for me, just because I was over there for like 8 hours a day, and I would be making more through that first scenario. Awesome. So you want to sort of get some information before you make some of these choices. So awesome job, everybody. Perfect. Wonderful. Let me move my pen out of the way, clear my ink, and let's take a look at the first activity. So we're in our book now. If you're in your textbook, you're flipping the page. And if you're on the slide, you're going down to slide number 4. So this table here, it's split into 2 columns because it was tall and there wasn't enough room. It would be too small. The amount of water in 2 tanks every 5 minutes is shown in this table. So if you're looking in your text, it says, so at 0 minutes, tank A has 25 liters and tank 2 has 1,000 liters. After 5 minutes, these are the new total amount of water. What I want you to do is I want you to look at this table right here. And for number 1, it asks you to describe. It asks you to describe what is happening in tank 1 and in tank 2. So in the textbook, it says using pictures or verbally or write a few sentences. I want you to break it into 2 sections, and I want you just to tell me what's happening in tank 1 and tank 2. Okay? So let's not do pictures for right now. What I want you to focus on is give me a sentence for what's happening in tank 1, what's happening in tank 2. Okay, we're going to take about 1.5 minutes to do that as well. If you finish early, take a look at some of the questions that follow down below. These 2 tables, what's happening in tank 1, the amount of money in tank, or the amount of water in tank 1, and what's happening with the amount of water in tank 2. Like I said, if you finish, take a look at questions number 2 and 3. Start to get some ideas for those ones. Taking another working 14 seconds. 14 working seconds, and then we're going to come back together and discuss what is going on here. What is this information telling us? Okay, so let's take a look at tank number 1. So if we look at tank number 1, what did we think was happening in that tank with the water that's in that tank? Gwen? The liters are going up, so the amount of water is increasing. Good. Did anybody look at the numbers and tell me how much it was increasing by? Adam? 150. It was liters per every what? Per every 5. per every EV, ERY, 5 minutes. Perfect. Wonderful. So it was increasing 150 liters per every 5 minutes. Very good. Now, what's happening to the water in Cindy? What's happening in tank number 2? What's happening to the amount of water in tank number 2? Throw it in the chat for me, please, Cindy. And I want you to think about what is the number that whatever is happening, what is it changing by? So so Cindy, how's it changing? The amount of water in tank number 2. The amount of water is decreasing. Awesome job, Cindy. So it's decreasing. Help me to decide how much it's decreasing by. Abby. By 100 liters every 5 minutes. And if I were to write that like as a fraction, it would be 100 over 5, which would simplify to 20 liters per minute, right? And then this one would be 150 for every 5, which would simplify to 30. Nice job. And if I am talking about decreasing the amount of water, the change would not be a positive 20, it would be what kind of 20? It would be a negative 20 because the amount of water is going down, our rate of change, or we're going to talk about it in the next few lessons, the slope of it would have to be negative because it's going down. Good, awesome. So we're using the table to estimate when the tanks have the same amount of water. When are the tanks, Gwen, can you close that Chromebook for me, please? When are the tanks going to have about-ish the same amount of water? We're really only going to be able to, looking at this table right now, we're only going to be able to find a range. Who can look at that table and tell me what is the range that it's going to have the same amount in each tank? Ooh, Kyle's ready. 15 to 20 what? Minutes. Very good. Here's the thing, I always spell minutes wrong, so I don't even know how. It just could be spelled wrong. Okay, I don't know. So let's prove that by looking here. So we're trying to find when each column is going to have the same amount of water. So we have 800 and 325. No, that's not really, no. Okay. 475 and 700. And then 625 and 600. So it's going to fall somewhere between these two, but we don't know when. What I need you to do now is grab out your calculators. We're going to be solving some equations. And let's go back to this slide here, and it's going to ask us, oh, I just erased that, I shouldn't have. 15 through 20 minutes. We don't know exactly when, okay? But now we're going to figure out a way that we can find the exact time when they're going to have the exact same amount of water in it. So the amount of water in liters in tank 1 after t minutes is 30 t plus 25. Oh, did I do that? I did that math wrong. 25. No, this one is 25. Yes. No. Someone do that calculator?
It is 30.
Well, let's look back because the book is never wrong. Okay. That's weird. Okay. Well, let's look at the equations that they gave us. So they gave us two equations. So they said for tank 1, after after T minutes, how much water is going to be equal to 30 T plus 25. Okay? Oh, because the original 25. I don't know. The amount of water in liters in tank 2 after T minutes is negative 20 T plus the starting value of 1,000 liters. Did everyone see those two equations? So the tank A, or tank 1, because it's increasing, has a positive change here, 30 T plus that original 25 that it started with. Okay? Oh, because, okay, yes. So then tank 2 is going to be negative 20 T because it's taking out 20 liters per every minute, every T, plus the original that it started with 1,000 gallons. Okay, so we need to find the time when the amount of water will be equal. So that means we need to take these two equations and we need to set them equal to one another. We want to find the spot where they intersect. We're going to set the two equations equal to one another and solve for x. So what I want you to do in your textbook, because you have a little bit of space, you're not gonna need to take out a piece of paper. People at home, if you're on the slides, you might want to grab yourself a piece of paper, and we're going to set the two equations equal to one another. Okay, let me show you what that means. Okay, so we're going to take that equation for tank A, which we said was 30 T, no, it was 30 T plus 25, plus 25. And we're going to set it equal to our second equation because that's going to tell us the exact spot where they have the same amount. What was our second equation here? Nice job, Dave. What was the second equation? Peyton, go ahead.
Negative 20T plus 1,000.
Negative 20T plus 1,000. Okay, so now we need to solve this guy for x. Do you guys want to take 1 minute to try it independently and then come back together, or do we want to go through it together? I'm going to give you a minute because some of you guys already look like you're working, so I want you to try it. You're going to need your calculators probably, and I want you to try to solve this. Take a minute and a half and try to solve this for x. People at home, do the same thing. Get a piece of paper for yourself. Try to solve it for x. Get your x's to one side, your variables to one side, your constants to the other, and then probably divide to get that x to be a single x. You got it. Okay. Oh, do it out on paper. Guys, it's going to be really important that you do this out on paper because when you go to take the quiz on Wednesday, I'm giving you points for all your steps. So if you just give me the answer, you only get like half a point out of the total 3 points that it's worth. So every step is worth a point. You need to show me every single step when you solve. That's the most important piece of this. My friends at home, if you got an answer, throw it in the chat. We're going to compare. I want to know what answers you got. T is equal to what? Give me your answer in the chat. So looking at this equation, this expression here, right? Because expression is we have the whole, both sides of this. So looking at this expression, do I have to distribute? Do I have to combine like terms? No combining like terms, no distributing. So we're at a pretty good point. I mean, I know we have some big numbers here, but we're at a pretty good point. Nice job, Gabe. Thank you so much for that. We're at a pretty good point in the game. We only have 2 or 3 steps that we need to do here. So There's really two things that you can do first here, because I'm not trying to limit you and say you need to move the x's first, then the constants. It's your choice. So what did you guys look at this and say that you needed to do first? Sadie, what are you thinking?
I got two variables to one side.
So she combined her variables to one side. She moved her x's, in this case t's. Good. And which one did you decide to move?
The -20.
Okay. Why did you choose the -20?
Because it's smaller.
Good, because this -20 is smaller than this 30. Good. And so how did you bring that whole 20t, that -20t, over to the other side?
I cancel it out by adding it to that side.
Good. Add 20t, and then to my left side?
I subtracted it.
Well, you do the same thing to both sides. So what would you really do?
I
Add it to both sides. Very good. Because you added 20t to the right side, you have to add the 20t to the left side as well. Good. Who can pick up where she left off? Junior, help me out.
50t
50t
plus 35 equals
1,000. Very good. So, one more. John, what was your next step here? Well, maybe you did a different next step, but looking at this, what would your next step be? Because we want to get our constants over to the left side, because our variables are on the right side. Very good, nice job, John. So we're going to subtract 25 from each side. This is where I said the calculator might come in handy. I am left with what on my left side, Abby? Yep, 50t. 975, very good. Oh, I put that on. 975. Good. And then how do I isolate my t? Kyle. Divide each side by what number? 50. And who, when you plugged it into your calculator, Max, what'd you get?
19.5.
19.5 is equal to t. And then what would the, nice job, Gabe got that one correct. Nice job, Gabe. And what would be the label that you would leave this or put with this? Go ahead. Minutes, very good. So 19.5 minutes is when both tanks will have the same amount of water. When we want to find the intersection point of two equations, when you're given two equations and you want to find the intersection point where they will meet, you have to take each one and set it equal to the other. Does that make sense? Sort of, maybe a little bit. We're going to do another problem with that looking forward. So awesome job here, my friends. If you didn't get this at home, please make sure you're writing it down. If you didn't get it here, make sure you're also writing it down. Okay, wonderful. We're going to move on to, in our text, you're just going to look next door at this example 17.3, elevators. Bless you. Actually, we're going to answer some questions about this first, and then we're going to look at elevators. Okay, so we're talking about this water tank, these water tanks here again. We're going to answer some questions about it. What does T represent in our first expression and in the second expression? So that variable T stood for what, Peyton? Time. Very good. Time. In what? More specifically, time in, Adam? Minutes. Very good. You don't, if you're in your textbook, you don't need to write this down. We're going through this together, and I like to sort of write it down. So that's why I am taking the time to write this down. So after we substitute a time in for T and simplify one of the expressions to be a simple number, what does the number represent? So if you had the expression, if you had the equation 30t plus 25, right? And I plugged in 5 here and I solved for a value, what would that number represent in the context of this story? So if I took a number and plugged it in and solved and got 30 times 5 is 150 plus 25 is 175, what would that 175 represent? The amount of what? And if I were to take the expression 32 plus 25 and plug 5 in for it, plug 5 in and solve to get this 175, what would that represent? 175 what is the liters, the amount of water in the tank, right? The units would be liters. And what the number represents is the number or the amount of water in the tank. So once again, we're talking about context. Every single unit, multiple times each lesson, I'm going to talk about context. Okay? So at the first half, the first couple lessons in this, I didn't talk about context because we were learning about solving, right? Isolating, getting our X. Now we're going to be talking about word problems, story problems, and I'm going to be asking you, what does it mean in the context of the story? 175 represents the amount of water in the tank, in tank A to be exact, after 5 minutes. And the unit is going to be liters. So you need to remember that you need to think about what these values mean in the context of the story. In the story could just be you're given a graph and the axes have labels on them and it says number of hours, pieces of cake you ate. That could be everything that you have. And so it would be the number of, or the number for that one would be the number of pieces of cake you ate after 5 minutes or something like that, like something crazy like that. But you always need to think about context. I am always going to be saying to you, context, context, context. What does it mean in this story? And remember, you're not always going to have an elaborate paragraph long story. It could literally just be you're given a graph with some labels on it. And you need to extrapolate sort of or pull out of it what are we talking about here? Okay. So when we made our estimate based on the table, was our estimate accurate?
Yes.
It was accurate, but was it precise? No, it wasn't very precise. But it was accurate in the way of like it fell between those two numbers. So we want to make sure that when we use this solving and setting two equations, two expressions equal to one another, it's going to give you a really precise answer. It's going to be like 17.5 miles per hour is the speed that they intersect at or something like that. So when you're looking for an accurate number, you're going to want to set the two expressions equal to one another. And then when you're looking for an estimate, you could always just look at a graph where they intersect on the graph or where the interval that they intersect on your table. Okay? So you're going to be looking for really precise numbers, but you could also be looking for estimates. Estimates can be found in graphs, in tables. When you're looking for a precise, exact answer, you're going to want to set your expressions equal to one another and solve. Does that make sense? So there's going to be two types of answers you're going to be asked to give, precise and estimates. And you're going to need to make a decision, when do I use each one of them? Okay? Boom, we already talked about that in the last piece. So let's take a look at elevators now. So if you're at home and you're looking at the slides, I want you to slip and slide down to number 9 in your textbook. You're just going to look at 17.3 elevators. Okay, so a building has 2 elevators that both go above and below the ground. We have a little diagram for ourselves here. Okay, at a certain time of day, the travel time it takes elevator A to reach a height of h in meters is let me just grab my pen. Point, so 800ths times h plus 16 seconds. Okay, the travel time it takes elevator B to reach a height h in meters is negative 0.8 or 8/10 h plus 12 seconds. Okay, so we have two equations here. These guys are kind of, I would say, probably the more complicated types of equations that we're going to be dealing with in this section. So we have, if we look at these changes here, so one of them, elevator A, has a rate, the rate of change is this piece attached to our H here. What kind of number is that? The first letter A, elevator A. It's not going to be negative, it's going to be a positive, right? So we have a positive rate of change here. This guy down here, if we look at it, is a negative 8/10 h. So this is going to be a negative rate of change. That's going to be important to remember and sort of distinguish here. So we have these two equations, which are in your text that we can refer back to. So now, first thing we're going to do with these two equations is let's look at slide number 10. And what is the height of each elevator at this time? And this time, you're going to be plugging in 0 for, so it's going to be like y is equal to 0.8 h plus 16. You're going to be plugging 0 in for the far side of the equation. The other one would be y is equal to negative 0.8 h plus 12. You're going to plug 0 in to solve here. So for both of these equations, I want you to plug 0 in on the opposite side of the equal sign, and I want you to solve h is equal to what? We're trying to find the height of both of these when we plug 0 into the opposite side of the equation and solve. Grab yourself a piece of white line paper if you don't have enough space in the book. I was able to squeeze it into the book, but if you want to grab yourself a piece of paper, you're gonna solve each equation, plugging 0 in for the opposite side of the equation. Does that make sense? Make sense? Okay, so I'm gonna give you 2 minutes to do that now. You're probably gonna need your calculator. Okay, so my friends at home, I want you doing the same thing. I want you to take each of the equations like I showed you on the Zoom screen right here. And I want you to plug 0 in. I want you to plug 0 in to each one of them on the far side. So H, you're not plugging it in for H, you're plugging it in for Y. Okay. So I'm going to come here. Insert a blank slide. This is going to sort of be my work slide so that we have some room. That is your job. I'm going to give you another 30 seconds. I'm going to give you another 30 seconds. Plug 0 into both equation and solve it. We're going to take about 5 more seconds. We're going to come back together. There we go. So I rewrote A, plugging 0 in for Y. So if I look at this equation, if I look at what I have here, I'm in a really good spot, actually. I mean, I have some decimals, which is kind of stinky, but like, it is what it is at this point, right? But I have my H's all to one side, right? If I look at it, all my H's are on which side of the equation? Kyle?
Right side.
The right side of the equation. So I don't even need to move my H's or do anything with those yet. I need to move my constants. So how am I going to move my constants here? What am I going to do to each side? Ian?
Subtract 16 from both sides.
I'm going to subtract 16 from both sides. Very good. So the left side, I'm going to be left with a what? Very good. Negative 16 is equal to 0.8h. Okay? So I'm done. Oh no. Gwen's shaking her head. Gwen, what do I have to do here? Good. Because this 0.8 is attached to the h by multiplication, I need to do some division to cancel it out. So I'm going to divide by 0.8, divide by 0.8. And if you use your calculator, the height is going to be equal to what number, Connor? Negative 20, and it would have a label of what? 20, what's the height? And we were talking about meters. Was it meters? Yes. Meters, very good. Fantastic. And I'm just gonna do like a N for a meter. Good. Nice job, Gabe. Thank you for being on it, dude. Let's take a look at B now. So I plug my 0 in for my Y, equals negative 0.8h plus 12. What am I doing here first, Adam? Huh? What am I doing first here?
You're subtracting 12 from both sides.
Very good. To undo this positive 12 on both sides, I'm going to subtract 12 from each side. Very good. And I'm going to be left with, Cam, what am I going to be left with?
Yeah.
Yep, go ahead.
0.
But remember, it's 12, it's 0 minus 12, not times. Negative 12, very good, is equal to, yeah, go ahead, sorry. I wasn't clear.
Negative 12 is equal to 0.8h.
Negative 0.8h, very good, nice job, Cam. What will be my next step here now? Kyle. Divide by negative 0.8, very good. Divide by negative 0.8, divide by negative 0.8, and let's see. Ava, what do I get when I divide? Negative 12 by negative 0.8. What do I get, Ava? H is equal to, what do we think, Ava? Find yourself a calculator. Nice job. 20. Is that what we got when we did it in the calculator? Negative 12 divided by 0.8. What do we get? 15. You were right that it was going to be positive, and you were perfect with that label of meters. We just want to make sure you use a calculator, type in negative 12 divided by 0.8, and you get 15 meters. And it's a positive because it's a negative divided by a negative would get me a positive. Awesome job, Ava and Ian. Perfect. Fantastic. I love it. So we had, if we go back to our, we have these answers written down for number 1. Let's take a look at number 2. Okay. So make sure that you have this written down if you don't have it written down. Here we go. we look back here, we have a height for A of -20 and a positive 15 meters. Very good. So how long would it take each elevator to reach the ground level at this time? So now, instead of solving for the height at that time, instead of solving for h, plugging 0 in for that t for that time, now we're going to plug 0 in for what? We're looking for the ground level, which we can represent that as what number? 0, right? We're going to plug 0 in for the which value? The h, or the height. Very good. So now we're going to take both of those equations again, but this time we're going to plug 0 in for the height. So we have y is equal to 0.8 h plus 16, and y equals -0.8 h plus 12. So this time we're going to plug our 0 in for our h and solve. So now I want you to take another minute and a half right now to solve each one, but plug 0 in this time for the h, for the height. Okay? Does everyone understand what I'm asking you to do? Perfect. Go ahead. Take this minute and a half. So for each one of these, you're going to plug 0 in for h this time, and you're going to solve. Space here. This one's not too bad. I'm going to give you another 15 seconds. 15 working seconds, and then we're going to come back together. Kyle has the first one, so I'm going to have Kyle help me with the first one.
I was actually asking if I could get a piece of line paper.
Oh, yeah. Does anybody else need a piece of line paper? No, I didn't do that. Okay. Okay, we have about I'm going to give you about 22 more working seconds, and then we're going to come back together and solve. These guys aren't too bad. So let's take a look at this guy, and I'm going to have John help me with the first one. So we're taking 3 more seconds, and then we're going to come back together. Okay, so John, I'm looking at elevator A, and I plug 0 in for h this time. And when I do that multiplication, I get y is equal to what, John?
16.
Do I have to do anything else? No. So y is equal to, how long is it going to take the elevator to get back to the ground floor? How many seconds? 16 seconds. Okay, so it's going to take me 16 seconds for the first elevator with the positive slope to get back to the ground floor. So now if I'm looking at B here and I'm solving, Cindy, I have y is equal to -0.8 times 0 plus 12. So how long is it going to take, Cindy, for elevator B to get back to the ground floor? I multiply here and I get a 0 plus 12 is equal to my y. So how long is it going to take, Cindy? 12 seconds. Very good. Y equals 12, and we give it a value, a label of seconds. Fantastic job, Cindy. Everyone see what we did there? We plug 0 in for different variables here, and we get different values. So when we plug 0 in for our h here, it's going to tell us how long it takes for it to get back to the ground floor. So it's going to take 16 seconds for this first one, and it's going to take 12 seconds for this second one. All right. So if the two elevators travel towards one another, at which height do they pass one another? So when we're trying to figure out when are they going to intersect, when are they going to cross paths, how do we do that when we have two equations? What do we do to them? We set them, Max?
We make them, we put one on the left and one on the right and put an equal sign.
Very good. We set them equal to one another. So if I come onto my work slide here, you guys have a little bit of space. There's not the most amount of space, so you might need a piece of line paper. Does anybody want one before I get started? Nope. So I have to take my two equations now, and I have to set them equal to one another. So that's going to look like 0.8h plus 16 is equal to, what's the right side going to look like? Junior. 0.8h plus 16 is equal to, go ahead. Oh. Very good. Very good. So we're setting those two equations equal to one another. What would be my first step here? There's two first steps that you can take. I'm not tying it down to either one. What are we doing first here? Adam, I love it. Go ahead. Subtract 12 from both sides. So he's moving his constants first. You can move your x's first, or your variables first, or your constants. I love it. I love that choice, Adam. Minus 12 from each side. And I'm going to be left with 0.8h plus what? Kyle? 4 is equal to, Kyle? Negative 0.8h. Very good. So I got my constants to the left side. I'm going to move my variables to the right side. This is going to give us some negative numbers, but that's completely fine. How would I move it here? Connor, I haven't heard much from you today. Minus, so I'd want to move this guy, so we'd minus 8/10 h from each side. And when we subtract these, what are we going to be left with on the left first? Gwen? 4 is equal to? Adam?
Minus 0.16.
So it'd be 1.6h, because we're adding them, not multiplying them. Good. And then how do I isolate my h here? Cam. Peyton, sorry, Peyton.
Don't you divide 1.6 by 4?
Very good. Both of them, we're going to divide both sides by negative 1.6. Very good. Make sure that negative stays with it, because you can't have a negative, if you don't take it with it, you'd have a negative h, and then you'd have to like divide by negative 1. Don't do it yourself. Divide by negative 1.6. And when we have our calculator and we do it out, what do we get as an answer? 4 divided by negative 1.6 gets me, Kyle? negative 2.5 is equal to what? H. So that's going to be the height at which they're going to meet. And now we need to figure out how long is that going to take us. So we know what the height at which they're going to meet. They're going to meet at negative, or like in the basement, 2.5 meters down. And now I need to figure out the time. So I can take either one of my equations, because both equations are going to get me the same number. I pick one of them. And I'm going to take this number and plug it in to the equation for H and solve it. So if I take, for example, I wish I had like scooted it either way. So I'm going to take, for example, y is equal to 0.8h plus 16. And I can plug negative 2.5 in where in this equation? To find the time, I need to plug 2.5 in for Abby. Well, we already said it was equal to h. Very good. So we take this original equation and we're going to plug it in for our h, because this is the height at which we meet. We meet at negative 2.5 meters. We want to find how long it's going to take, so we need to solve for our time, which is our y. So y is equal to 0.8 times negative 2.5 plus 16. I'm sorry, I know that's kind of pinky, but like that. Plus 16. Who can help me out? Ian has his calculator open. Help me out.
Well, you do 0.8 multiplied by negative 2.5, and you get negative 2.
Negative 2 plus what?
Plus 16.
Okay, plus 16. And then it would combine to y equals 14. So, so this would have a label of 14 what? Seconds. Very good. So the first thing that we had to do was first we had to set the two equations equal to one another to find the height at which they would meet. Does everyone see how we did that? Then when it asked us at how long it would take to get to that time, we picked one of our equations. You can pick either one. I just grabbed the first one because first one. And you plug it in for the variable you just found, and then you would solve. So ladies and gentlemen, we will be finishing this up tomorrow. Please make sure that on Thursday, please make sure that you save this. My friends at home, awesome job. Listen, you're not leaving, don't leave. What I need you to do, I'm gonna be putting you guys into the waiting room, and you will be joining back in for period 2. So please make sure that you do not leave. You will be put into the waiting room.